Welcome back, folks. We're introducing a new component, and I'm introducing it here because if you can do nodal analysis, you can analyze any circuit with this type of component in it. A lot of people get intimidated by this. You're not going to be intimidated by it. It's simple. Okay, there's just a couple things we have to do to alter nodal analysis, and you can handle any of these circuits. This is the operational amplifier. All right, so it looks like this. And I really just put this up here to scare you, but that's really an operational amplifier. You can see a bunch of transistors in there, things that we're not going to get to this semester, but you might get more comfortable with these types of components in future semesters. We're going to look at the ideal operational amplifier. This one is kind of as real as it gets, and analysis around that is still possible with nodal, but a little more complicated. We're dealing with the ideal operational amplifier, and it looks like this. Okay, so let's look at some important things here. So it's got two terminals over here on the left, and those are the inputs. Okay, and then it's got this one over here, and it's an output. Okay. Operational amplifier, we use it for just about everything. It's on the front end of an oscilloscope. A lot of measurements are taken with operational amplifiers. There was a time when you would build control systems out of operational amplifiers. We tend to do that digitally nowadays, but it's not unheard of. Anyhow, so we're going to build things out of this. It's a way we make a signal bigger. So if you have some of them in your pocket, if you have your cell phone in your pocket or maybe on your desk, if you have a radio receiver and you have a really small signal coming from whatever the transmitter is, whether it's a Wi-Fi transmitter or radio or something along those lines, there's probably an operational amplifier in it. Okay, so it's taking the information and the signals, voltages and currents on the inputs. It's making them bigger if you set up the circuit correctly, and it's putting it out on the output. Okay, so we've got inputs on the left here, outputs on the right. These pluses and minuses are labeled for the non-ideal case. When it comes to analyzing an ideal operational amplifier, they don't make much of a difference to our analysis. All right, we're going to make two assumptions about the ideal operational amplifier that allow us to apply nodal analysis. Okay, and here they are. So assume, because it's ideal and only because it's ideal, assume that the voltage at the negative terminal, okay, and the voltage at the positive terminal are equal to each other. That's it. Okay, so if we have some voltage here and some voltage here, both in reference to ground, then they're going to be equal to each other. Okay, easy enough assumption. We're going to end up with two nodes that have the same voltage. Okay, second assumption, and this can be drawn either way. Okay, let's call that the current there and the current here. Okay, I minus and I plus. Those currents don't exist. There's nothing going in or out of the inputs. So in plus, the current plus and the current for the minus terminal are both equal to 0. That's handy because we can write KCLs for those nodes. All right. Here's what to avoid. This current, there actually is some current there. Okay, we can call that I out. Okay. And we can't make assumptions about that current. Make no assumptions. Make no assumptions. About I out. Okay, on the outputs, there is some current flowing in or out of it. This thing's whole purpose in life, and I wish my purpose in life was as clear as the op amps. This thing's whole purpose in life is to push current in or out of the output to force this assumption to be true, that these voltages are the same. Okay, it's going to do that through a network of resistors, and we're going to have to analyze that network of resistors. So that's what's coming in the next videos. This one's nice and short because I just want to get those assumptions out there. In the very next video, I'm going to look at a common op-amp circuit, and that common op-amp circuit, we can go look up the formula in a book, which is fine if you're only ever using op-amp circuits that you can get out of a book. But if you have a circuit that doesn't look like a textbook problem, what do you do? And the answer is you do nodal analysis, and I'm going to show you how to do that. So we're going to start with some common ones that maybe we can find the information in a book, but I'm going to start you out performing nodal analysis on those, and then we'll move to some more complicated op-amp circuits. Okay, stay tuned and good luck.